Hello everyone. In the second video for the hiking tree problem, uh, we try to check the feasibility of all the possible solutions that we generated in the first video. So now we have 64 possible solutions for that problem. Now we want to check the feasibility based on the rules or the constraints that we have in the problem. So if we go back to the problem's description, we have one constraint here, and we have to make sure that the total weight of all the items, all the selected items, should not exceed that 15 kilograms, which is the backpack capacity. So going back to the Colab, we first need to know what are the weights of each item, and so we can assign them to a list, or we can ask the user to give us those numbers or those parameters. So we are going to use the input function, same as what we did in the first video. So the only difference here is that in the first part we just had one variable. We were asking about the number of items, so it was just a single integer. Here we have a list of numbers that are the weight of each of those 6 items. So we need to first of all has a list as an output, and also we need to just do the mapping to make sure that all of those users inputs, which are which will be string, because the output of the input function is a string, map them to their integer values and then give it to the list. And finally, as the output, we are going to have a list for item weight. And this split here also get rid of any spaces that the user may um, hit when entering those parameters. So if we run this line of code, so here is the message that we are asking the user to give us those parameters, and based on the problem description, these are the values. So we can give them the user those values. And if we press enter, we have a problem fit. And so here is the thing. Maybe I think I have a typo here. Should be. Yes, I have a typo here. This one. Sorry. 261, and here we go. Yeah. So now it works properly. So in the next line, if I print item weight, here is the list of the weights 5, 4, 3, 2, 6, 2. Okay. So we don't need this one. And here we go. So after getting those parameters from the user, we need to first we need to have a variable to store all the feasible solutions. So we define a variable, a list. We call it feasible solutions, which is an empty list. and we are adding every feasible, when we are going through all of those possible solutions to check if they are feasible or not, we add or we append those possible solutions to this empty list. And now here we need to check the feasibility. So since we have to check all the possible solutions, we need a for loop. So we said for solution in possible solutions, which is our output from the first step, possible solutions. We need to check the weight. So to check the weight, we define another variable. We call it total weight, and we set it equal to 0. So this is the total weight of every possible solution. So now we are checking the first possible solution, and we assign the total value equal to 0. Now we need to multiply those weight to their corresponding binary variables to see what is the total weight of each solution. So how we do that? We go through every element of each solution. So again, we need a for loop. We said for I in range of n, which is the length of the solution, total weight. We update the total weight. How we update the total weight? Total weight is total weight plus that multiplication. Solution I multiplied by item weight I. Whatever the value of this multiplication, we add this to total weight. We go to the next item, we calculate this one, we add it to the total weight. So by the end of this for loop, we have the total weight of that solution. When the for is done, we need to check if the total weight exceeds 15 kilograms or not. So if total weight is less than or equal to 15, what do? We append that solution to the feasible solution. If it is the case, if the total weight is less than 15, so it means that it is a feasible solution. So we add it to the feasible solutions list, and then we go to the next solution, and we are still in this outer loop. So we check this. We do this procedure for all of the possible solutions. When we are out of that for loop, we need to print feasible solutions, and we also see how many feasible solutions do we have. So if we run this one, so we had 5, 4, 3, 2, 6, 2 as the item's weight, and here is we have the possible solutions is not defined, so we have the possible. Okay, so I need to run this line of code before that. So we had 6 items, so here we have the number. Now we need to run it again. 5, 4, 3, 2, 6, 2. Press enter. Here is the case. So we have all the possible solutions, and among those 64 possible solutions, we have 52 feasible solutions. So now we have all the feasible solutions. In the next video, we will try to evaluate each of those feasible solutions and choose the best among them.